Okay, let's think about this one. What's the limit of sine x over x when x is into 0? It's 1. We did this a long time ago. I'm just trying to see if you still remember that. Here's the second question that looks very similar to the previous one, but it's actually a lot different because now x is sent to infinity. What do you think the answer to this is? It should be 0. Well, why did you think that? Okay, I mean, here's an intuitive way of arguing that sine x over x goes to 0 as x goes to infinity. So, sine of any angle, I don't even know what this angle is. Can this exceed 1? No. Can this be less than -1? No. So even if I don't know the value of this theta, for any theta, I can always confidently say that whatever this angle is, the value should be between -1 and 1. Right? So intuitively, this is what happens. If, say, x is 1,000,000. What sine of 1,000,000? Do you know the value? No, and neither do I. I have no idea what sine of 1,000,000 is. But that's okay. I still know that it's a value between 1 and -1. Right? And I'm dividing that by 1,000,000. So what's that close to? It's almost 0, right? If you divide a number that's between -1 and 1 and you divide by 1,000,000, that's very close to 0. Okay? And you can say the same thing for like x being trillion, quadrillion, and so on and so on. Okay? There's a formal way to argue that this limit is 0, which I don't require people to know, but it's still helpful nonetheless. So let me sketch it here. Okay, so you can start by saying sine x is between 1 and -1, and let's say x is some big value. X is at least a positive value, which is very big. Now in this case, I can say sine of x divided by x is between 1 over x and -1 over x. Isn't that right? I can divide this by x, both sides, and because I have x positive, the inequality doesn't change. So this is still true. And once we're confident that this is true, now I can say, I can take the limit of everything. Limit, x going to infinity, x going to infinity, x going to infinity. So, in other words, if this inequality always holds, then even if you take x to be a very, very large number, this inequality should still hold. Right? And then, think about what this value is. What is the limit of 1 over x as x goes to infinity? 0, because you're dividing 1 by infinity. How about this? It's negative of 0, right? 1 divided by infinity, and you put this negative. Negative of the 0 is still 0. So because both sides can be evaluated, at the end of the day, the inequality that I end up with is this limit x going to infinity of sine x over x, which, I mean, we already kind of had the feeling that it should be 0, but now we have a proof. The limit has to be between 0 and 0. What number fits between 0 and 0? 0, that's the only thing. So that's the proof. That's why this has to be 0. But even without going through this logic, you can still convince yourself that that value has to be 0.